Page 94, number 104 is an interesting problem. The directions are solve. And so when you have to solve a problem, there's lots of methods that you learned last year. You learned factoring. You learned square root both sides. You learned complete the square. You learned quadratic formula. In this particular problem, since there's two parts to it and it's not obvious how to use the quadratic formula on this one, I would choose to factor. So I noticed that these two terms are common. So what happens if I factor out x plus 4 to the 1/2? So that means I'm going to put a coefficient in front of this as a 1 just to help me out here. So if I take x plus 4 to the 1/2 from here, it just leaves a 1. If I take x plus 4 to the 1/2 here, it leaves the 5x, and it leaves x plus 4 to the 2/2. But I'm going to call that 2/2 just to the 1, because now I can do another step, distribute. So x plus 4 to the 1/2 times 1 plus 5x squared plus 20x. You with me so far? These are all equal to 0, right? Now does this part factor? Well, let's rewrite it first. So x plus 4 to the 1/2 times 5x squared plus 20x plus 1. And after a lot of thought, I realized this doesn't factor. If it did, I'd put 2 parentheses, and then I would have 3 parentheses multiplied. Once you have the problem factored as much as you can set each one of the factors equal to 0 and solve them, and that gives you the solutions to the problem. So this one, x plus 4 equals 0, x equals -4. That's one answer to the problem. Now, I try to solve this, it doesn't factor, so the only way to solve this part is to use the quadratic formula. So I know that a is 5, b is 20, c is 1. And using the quadratic formula, I'm not going to do that part. I'm just going to give you the answer here. Hopefully, you should know how to use the quadratic formula. All over 5. So, why don't you try that problem? So, factoring. If you can factor into a number of parentheses, all multiplied by each other, then set each one equal to 0. Another example, you might get something after you factor it. You'd have x plus 3, x minus 5, 2x plus 10 equal to 0. In this particular problem, you'd get 3 answers. You'd have x equals -3, x equals 5, and 2x equals -10. So x equals -5. You could get 3 answers to a problem. So you've done these problems before, so good luck, and hopefully that helps. Okay, here's another tricky problem to solve. This is like on page 94, like number 129. Solve that thing. So first of all, it's a fraction, so you need to be careful of values that make this solution unsolvable, because you can't have zeros in the bottom of a fraction. But first of all, let's get the whole problem equal to 0. So we're going to move this fraction over to this side. So I'm going to rewrite this. 1 over x plus 3 minus 9 over 4x plus 3 less than or equal to 0. And you know what? I wanted this one to be x minus 3. I copied it out of the book wrong. Sorry about that. Okay, so now, how do I solve this? Well, let's get this to be one fraction. So common denominators, right? So multiply this one by 4x plus 3 on the top and bottom. So my whole new fraction is going to have the bottom x minus 3 and 4x plus 3. I'm going to multiply this by 4x plus 3, and I'm going to multiply this one by x minus 3, and we still have this symbol here. So what happens? I get 4x plus 3 minus 9x plus 27. Be careful of that sign, right? So make that minus 9. There. Okay, let's add like terms. What do we get? looks like 30 minus 5x on the top, and the bottom, x minus 3, 4x plus 3, and less than or equal to 0. So now I've simplified it about as much as I can. So the solution to this could be any numbers in the real number system except some certain critical values, the values that make the bottom 0 or the values that make the top 0. So what are those critical values? Well, 30 minus 5x equals 0. If you solve that, you know what you get? Yeah, x equals 6. I'm not going to solve that for you. You can do that yourself. X equals 6. So, critical values. One of them is x equals 6. All right, if I set that equal to 0, x minus 3 equal to 0, I get x equals 3. So 3 is another critical value. X equals 3. Let's put them all up there. All right, how about this one? Well, 4x plus 3 equals 0, so 4x equals negative 3, x equals negative 3/4. So there's another critical value, x equals negative 3/4. So the answer to this problem, if I want to graph it on the number line, which is kind of the best way to look at it, I need to think about where are those critical values first of all. So let's see, we have 0, 1, 2, 3, 4, 5, 6, negative 1. So negative 3/4 is going to be right about there, right? Negative 3/4. My 3, that's another critical value, and my 6 is a critical value. So how do I get the answer? How do I figure out what numbers on the whole number system could work in this equation? So it's key to look at this equation, right? And now to find out, all you do is you test some values. And if you test a value in all the areas looking at the critical values, you'll be able to find out if it's true. And if you check negative 2 in this equation or in the original, it's safer to go back to the original, you'll find out that it doesn't work. If you check something in here like 0, or 1 or 2, you'll find out that those might work. So then what you do is you can graph 3/4, you can't include 3/4, all the way to 3, and those numbers will work. And then starting at 6 works, 7 works, 8 works, 9 works. So you can test those yourself. Basically, when you're solving a complicated problem like this, get it on one side of the equal sign. If it's a fraction, you have to look at critical values. If it's not a fraction, then you can use quadratic formula or many other ways to solve a problem. Fractions are a little bit tricky. So if you go and test values here, you'll find out that this graph shows areas where I can get answers to that problem. So you can try that, and good luck on the rest of the problems.